Hi guys, so this is a full walkthrough of the Eduqas GCSE Mathematics Foundation Tier Paper 1 from Summer 2024. So Foundation Tier Component 1. Okay, let's get started. So we have our formula list at the front, don't forget about that. So you've got surface area and volume formulas, and you've also got your SUVAT formulas as well. So you don't need to recall those as you're working through the paper if needed. Okay, question 1A. Write down the value of the 2 in the number 1.27. So the 2 here is the place value column after the decimal point. That's the tenths column. So I can say that this is 2/10, or I can also write it as 0.2. It doesn't matter which of those I give them as my answer. Part B, write 32,928 correct to the nearest thousand. Okay, so the nearest thousand, so we've got 2 in our thousands column. We look at the number next to it. So that number next to the thousands column is 5 or above. So we're going to round it up to the next thousand. So that's going to be 33,000 to the nearest thousand. It's important that those zeros are there on the end because that maintains the highest place value. Part C, write down the value of 8 squared. So 8 squared is 8 times 8, and 8 times 8 is 64. Part D, calculate 20 plus 4 divided by 4. Remember, order of operations, we have to do things in the correct order. We need to do that division before we do the addition. So we've got 20 plus, and then it's 4 divided by 4, which is 1, and then 20 plus 1 is 21. E, calculate 0.4 plus 0.21. So I'm going to use column method. So I've got 0.4. What's important here is I align my columns. So my decimal points need to match up and be aligned. So what you'll notice here is I have a gap above the 1 in this column. So I'm going to put a placeholder 0 there. And then I'm going to add. So 0 plus 1 is 1. 4 plus 2 is 6. 0 plus 0 is 0. So 0.61 is our answer. Best to put that into columns, guys, so that you get the place values lined up accordingly. F. Write these numbers in order of size. Start with the smallest number. Okay, so negative numbers are smaller than positive numbers. And the more negative a number is, the further away it is from 0. So if we look at negative 7.5 and negative 7, negative 7.5 is further away from 0. So that's going to be my smallest. Then it would be negative 7. So now I need to compare 3.2 and 5. Well, once I get to 0, my numbers start counting up in the positive direction. So 3.2 would come before 5. And then for G, write the following inequality in words. So we have minus 4 is less than, because that's the less than symbol, X. Okay, so I'm going to write that out in words. Minus 4 is less than X. You don't have to write the minus 4 as the word for, but it's more the inequality that needs writing in words, and that's where the less than comes from. Question 2. Louis has a bag containing 10 coloured counters. He chooses one counter from the bag at random. Part A. There's an even chance that Louis chooses a blue counter. How many blue counters are there in this bag? So an even chance is a half. So that's 50-50. Half a chance. So if it's an even chance that he chooses a blue counter, we have 10 in total. So half of those must be blue. So that's 5 blue counters. B, it's impossible for Louis to choose a red counter. How many red counters are there in the bag? If it's impossible, there's a 0 chance. So if it's impossible, there are no red counters in that bag to choose from. And then part C, it's unlikely that Louis chooses a yellow counter. So unlikely for a yellow counter. What is the smallest number of yellow counters that Lewis could have in his bag? Okay, so if it's unlikely, we want less than half a chance, and we want a lot less than half a chance, really. So we don't want it to match with any other possibility. So I say if it's unlikely that he chooses a yellow counter, the smallest number of yellow counters he could have would be 1. 1 out of 10 is an unlikely probability. 3A, write 3 over 50 as a percentage. So when we're changing from a fraction to a percentage, we want to convert our fraction so that it's over 100, because percentages work in hundreds. So we need to multiply the top and the bottom by the same thing to create that equivalent fraction. 50 times 2 is 100, so 3 times 2 on top is 6. 6 out of 100 is 6%. Part B, calculate 3/5 of 20. So what we need to do is split 20 into 5 equal parts. So we're dividing by the bottom. So 20 divided by 5 is equal to 4. And then we want 3 of those fifths. So we're going to do 4 multiplied by 3, which is 12. So 12 is 3/5 of 20. Part C, calculate 70% of 50. So I'm going to find 50%, 10% and 10%, because when I add those together, I get 70%. So to find 50% of 50, I need to half it. So 50 divided by 2 is 25. To find 10% of 50, I need to divide it by 10. So 50 divided by 10 is 5. I can repeat that here for the other 10%. And then if I add them together, that's going to give me my 70% total. So we have 5 plus 5 plus 5, which is 15. And then 2 plus 1, which is 35. So 35 is 70% of 50. Question 4A. Kelly is planning a family trip to the zoo. The 2 adults and 3 children will all travel in the same car. Each person will need an entrance ticket and lunch. The costs for the trip are, so petrol will cost £40. Tickets for adults and children, the prices are there. And lunch for adults and children, the prices are there. Kelly has £180 to spend on the trip. She pays for the petrol, tickets and lunches. How much money would she have left? Okay, so let's work this out. First of all, we have 2 adults, so let's deal with the ticket prices first. So for tickets, we've got 2 adults, which is 15 times 2, which is £30 for their tickets. We also have 3 children. That's £10 per ticket, so 10 times 3 is £30. So the tickets in total cost £60. Let's work out lunches. So lunch, again, we've got 2 adults. That's £12 per person. And then we have 3 children. So that's £7 times 3, which is £21. So for the total for lunch is £45. So we have tickets, lunch, and we also need to include the petrol. So I'm going to take total price for the tickets, total price for the lunch, and the petrol cost, and add those together. So 60 for the tickets, 40 for the petrol, and then 45 for lunch. So that adds to 5, 14. So it's £145 in total. She has £180. How much will she have left? So we need to do 180, take away the 145 that it costs. So 0 take away 5 I can't do and get a positive answer, so I need to borrow. 10 take away 5 is 5. 7 take away 4 is 3. 1 take away 1 is 0. So Kelly has £35 left. Part B. Last year, 10% of visitors to the zoo bought a bag of animal feed. This year, the zoo expects 650,000 visitors. How many bags of animal feed do they expect to sell this year? So 10% of those 650,000 visitors are expected to buy a bag of animal feed. So we want 10% of 650,000. So to find 10%, we divide by 10. So when 650,000 divided by 10 is 65,000. So we expect to sell 65,000 bags of animal feed this year. Question 5a. Circle the expression that is the same as 4 more than y. Okay, so if we're dealing with more than, we're adding. So we are doing 4 more than y. So we are doing y add 4 or 4 plus y. So we need to circle that equation. Part B, calculate the value of negative 8x when x equals negative 3. So this is substitution. Negative 8x is negative 8 times by x, but they tell us that x is minus 3. So we're doing negative 8 times by minus 3. 8 times 3 is 24, and a negative times a negative gives us a positive answer. So our answer is positive 24. Question 6. So we've got a coordinate grid and we've got the point A marked. Part A, on the grid, plot the point B, which is 5 minus 2. So to plot the points, we go along the X and then we follow for the Y. So we're going to go along to 5 here, and then we're going to go down to minus 2, which is there. So that is point B. Part B. ABC is a triangle with a right angle at C. Plot the position of point C. So ABC forms a right angle triangle. Okay. Now that tells us if the right angle is at C, then the line AB must be the hypotenuse, the longest side of the triangle. So I'm just going to draw that in for reference. So if I was to form a right angle triangle here, if I draw that on as best as I can, move you across a little bit. So that's where my right angle would form. So they've said with a right angle at C, so this must be point C. And it says to plot the position of point C, and I've just done that on there. So that's fantastic. And then part C, find the coordinates of the midpoint of the line AB. Okay, so we want the coordinates of the midpoint of this line. So there's a couple of ways you can do this. You can look at that line and see where the middle is. So I believe that that is the middle of the line there. So that would be the coordinate I'm reading off. If you can't see that, if you're not sure that whether that's the middle or not, plot the journey to get from A to B. So that it is 1, 2, 3, 4, 5, 6 down, and then 1, 2, 3, 4 across. The midpoint would be halfway. So we would go 3 down and then 2 across, which takes us to that point that I marked there, guys. Now we need to read off the coordinate. Remember, coordinates are x, y. So we go along to the x-axis first, which gets us to 3. And then along to the y-axis, which gets us to positive 1. Question 7. David has 6 cards. Each card has a letter on it. So we've got A, B, C, B, A, B. Part A, which letter is the mode? So the mode, okay, is the most common. So which letter appears the most often? Well, that's the letter B because it appears 3 times. 1, 2, 3, where the other letters don't appear that much. So the mode is B. Part B, one of the cards is chosen at random. Part 1, on the probability scale below, mark with an arrow the probability that the card chosen has a letter A on it. Okay, so how many letter A's do we have? We have 2 letter A's out of 6 cards in total. So 2 out of 6, guys. Let's have a look at our probability scale. So we're going from 0 to 1, which is good. And then we've got 1, 2, 3, 4, 5, 6 equal sections, which is handy because the bottom of our fraction is 6. We want to mark our arrow where 2 6 would be. So we're going to go 1 6, 2 6 to that point there. So we're going to mark our arrow on the probability scale there. Part 2, write down the probability that the card chosen has a letter C on it. Okay, so we want the probability. So remember, we've already said these probabilities are out of 6. How many cards have a C on them? Well, only 1 card has a C. So the probability that the card chosen has a letter C is 1 out of 6. Part C. Write down the ratio of the number of cards with a letter A to the number of cards with a letter B. Okay, so we want the ratio of the letter A to the letter B. Well, there are 2 cards with the letter A, 3 cards with a letter B. The only reason why I didn't write that straight on my answer line was just in case there was any requirement to simplify. There isn't, so I'm going to write that as 2 to 3 on my answer line. Question 8a, simplify 4 times W times 3 times Y. So everything's getting multiplied. So we're going to deal with those numbers first. So I'm going to do 4 times 3. So 4 times 3 is 12. And then I've got W times Y. Well, W times Y can be written as WY. And then this whole thing can be simplified and written as 12 WY. Doesn't matter which way around you write W and Y, as long as you don't have a multiplication symbol in there, because we're simplifying as far as we can. Part B. In each of the spaces below, write a term to make the statement correct. So our statement is F plus something, take away something, and we are getting an answer of 6F. So we need to figure out what terms with F in to put in those gaps. So that's 1F. So to get from 1F to this 6F, we're going to have a sum that results in 5F, because 1F plus 5F is 6F. So whatever I put in those 2 spaces needs to have a difference of 5, okay? So what I could do is I could add 7F and then take away 2F, because 7 and 2 have a difference of 5. And then when I work through this, 1F plus 7F is 8F. Take away 2F is 6F. Okay, you can put any answers in those gaps, guys, as long as they have a difference of 5F and it results in positive 6F at the end. So if I'd put the minus, if I'd have added 2F and then take away 7F, it wouldn't have worked. Okay, because I would have been left with a negative value of F. Okay, C, solve each of the following equations. So part 1, 6x equals 48. Inverse operations for solving. 6x is 6 multiplied by x. The inverse of multiplying by 6 would be to divide by 6. I have to do it on both sides. So 48 divided by 6 is 8. So x equals 8 is my answer. Part 2. A divided by 4 equals 40. So remember, this fraction, A over 4 is a division. Fractions are also division. So A divided by 4 equals 40. The inverse of dividing by 4 would be to times by 4. So when I times by 4, I get A equals, and remembering to do it to both sides, 40 times 4 is 160. Part D. Two Wheels is a bike hire company. Customers can hire bikes from Two Wheels for a whole number of days. The company uses the following formula to calculate its hire cost. We've got the bike hire cost is equal to £20 plus £15 times the number of days. So £15 per day, and then a standard fee of £20 on top of that. Tom wants to hire a bike from Two Wheels. He has £150 to spend. What is the greatest number of days for which Tom can hire a bike? Okay, so he's got £150 to spend. So let's see. So we have £20 plus 15 times the number of days. So let's call that D, is equal to 150. So let's see if we can find out how many days if it costs him £150. So we're going to solve this equation. So I'm going to do the opposite of adding 20, which is to subtract 20. So that's 15D equals 130. And then I'm going to divide by 15. So D is equal to 130 divided by 15. So I'm going to do some calculations here. So I'm going to count up in 15. So 15, 30, 45, 60, 75, 90, 105, 120, 135. So how many 15s go into that 130? 1, 2, 3, 4, 5, 6, 7, 8 takes us to 120. So that would be 8 point something, because we don't get another whole 15 in there before we get to 130. I can stop my calculation there because we want a whole number of days. So I can't have 8 point something days. So the greatest number of days that Tom could hire a bike for would be 8, because we can't hire for that point something of a day that he would have. Okay, question 9. The conversion graph below can be used to convert between acres and hectares. So we have hectares on our y-axis, acres on our x-axis. Use the graph to answer the following questions. So part A, how many acres are equal to 4.5 hectares? So remember, this is hectares. So I'm going to take my ruler and I'm going to line my ruler up to 4.5. So pay particular attention to the scale. So I can see that each set of 10 small squares is equal to 1. So each individual square must be equal to 0.1. So 4.5 would be here. So I'm going to draw a line from 4.5 to the conversion graph. So that's where 4.5 hectares falls. So if I turn my ruler around now, and where it joins my graph, if I line my ruler up, and then I draw a line down to cut the axis that shows acres, and then I'm going to read off the value that I think it is there. So from 10 to 12, okay, there's 10 little squares, but 10 to 12 is 2, all right? So halfway between them would be 11, which would be at this point here. So that would be 11. We're slightly over 11, okay? So you'd be okay saying anywhere between 11 and 11.2 acres, all right? So I'm going to go with, it's 11.1. So I think it's 11.1 acres are equal to 4.5 hectares. Just being really careful with that scale there, guys. Okay, part B. Complete the following statement. You must show all you're working out. 26 acres is equal to some number of hectares. Now, the thing we need to be careful of here is we can't do it exactly the same as we just did that previous question. Because if we look at our axes for acres, only goes up to 16 and we're interested in 26. So we've got a couple of options here. What we need to do is use a number of acres that we could then scale up. So we can read from our graph, but then we can then scale up to find 26 acres. So what I'm going to do, guys, is a little proportion table. So if we're doing acres and hectares, so half of 26 is 13. So I'm going to read off my graph and find out what 13 acres is in hectares and take it from there. So where would 13 be on this graph then? So 13 would be here. So again, you need your ruler. We're working the other way around this time. So line your ruler up where 13 is. Draw a line to where it meets the conversion graph. Turn your ruler around. Line it up with where it cuts the graph. And then read across to the other axes. So we are reading to this point here. Okay, so we said earlier with the y-axis that every 10 small squares is one whole one. So each square must be 0.1. So that tells me that 13 hectares must be 13 acres must be 5.2 hectares. Now I need to scale that up for 26. Okay, so to get from 13 to 26, I would multiply by 2. I'm going to do the same to the other side. So I get 10.4 hectares is equal to 26 acres. Question 10. A shop sells scented candles and is holding a sale. The original price of each candle was £3. In the sale, the candles are sold at half price. Sam has £38. Sam thinks that the maximum number of candles that she can now buy is exactly twice as many as she could buy at the original price. Is Sam correct? Yes or no? You must explain your reasoning. Okay, so we need to figure out how many she could buy at the original price and then how many she would buy at half price. Okay, so at the original price, so if we're working with the original price, she at £3 each, she has £38. We would do 38 divided by 3. So 3's into 3 is 1. 3's into 8 is 2. We do have a remainder, so we're going to pop that there. Remainder is 2. So 3's into 20. We could continue that, but the maximum she could buy at the original price with £38 would be 12. Okay, so maximum she could buy would be 12 because you can't buy point something of a candle. So now I'm going to find out how many she could buy at the sale price. So the sale is half price. So half of 3 is 1.5. So that would be £1.50 per candle. So we're doing 38 divided by £1.50. But what I'm going to do is I'm going to multiply both sides of this sum by 10. So I'm doing 380 divided by 15. And because it's a division and I've multiplied both sides by the same thing, whatever answer I get for this calculation is my final answer. I don't need to change it back. So 15's into 380. So that's 15, 30, 45, 60, 75, 90. 15's into 38 is 2, remainder 8. 15's into 80, 1, 2, 3, 4, 5. There'd be a remainder, but again, I'm not going to continue because we can't buy point something of a candle. So in the sale price, she could buy max 25. Now let's go back to the question. Sam thinks that the maximum number of candles she can now buy is exactly twice as many as she could buy at the original price. Is Sam correct? Well, 12 times 2 is 24, and 25 does not equal 24. So Sam is not correct. So we've shown some working out that explains our reasoning, and we've selected no. Question 11. Here is part of a train timetable between London Paddington and Bristol Parkway. So this is our train timetable. Important things to note. This column here tells us the train stops. So this train starts at London Paddington, stops at Bristol Temple Meads and Bristol Parkway at those times. So each one of these columns is a different train journey. Okay, part A. Darren catches the 1948 train from London Paddington to Bristol Parkway. How many minutes should his train journey take? So he is going on the 1948 train from London Paddington to Bristol Parkway. Okay, so we're going from 1948 to 2101 in time. Okay, so first things first, let's think about the hours that we would pass on the clock to get from 1948 to 2101. So we would pass 8 o'clock and we would pass 9 o'clock. Okay, so if we get from 1948 to 8 o'clock, that's the next hour. Remember, there's 60 minutes in an hour. So 60 take away that 48 means that is 12 minutes. And then from 8 till 9 is 1 hour, which is 60 minutes. Remember, we want it in minutes. And then from 9 till 9:01 is 1 minute. So we want the total minutes. So we are interested in 12 minutes plus 60 minutes plus 1 minute. So 12, 60 and 1. So that's 3. So 73 minutes in total. Part B. Jennifer lives in London. She went to an event in Swindon. So lives in London, went to an event in Swindon. She left her house at 6:10 p.m. It took her 10 minutes to get to London Paddington Station. She then took the next train to Swindon. This train arrived in Swindon on time. Then it took her 12 minutes to get to the event. The event started at 7:45 p.m. How many minutes late did Jennifer arrive at the event? Okay. So she left her house at 6:10 p.m. That's the first piece of information. So she left at 6:10 p.m. and it took her 10 minutes to get to the Paddington station. So when we add 10 minutes to 6:10 p.m., that gets us to 6:20 p.m. She caught the next train to Swindon. So let's have a look at the London Paddington. So if she got there at 6:20, that's in 24-hour clock is 18:20. So she missed that one. She missed that one. So it must have been the 18:43 train that she got. So she got the 18:43 train. She arrived on time into Swindon. So that 18:43 train arrived in Swindon at 19:37. It then took her 12 minutes to get to the event. So we're adding 12 minutes to her arrival time of 19:37. So 37 plus 12 is 49. So she arrives at the event at 19:49. The event started at 7:45 p.m. So 7:45 p.m. is 19:45. So we want the difference here now, guys, between 19:49 and 19:45. Well, the hour is the same. It's just the minutes that have changed. So to get from 45 minutes past to 49 minutes past, that's a difference of 4 minutes. So she arrived 4 minutes late. 12A. Lisa, Flynn and Jane each have a number of marbles. So we've got Lisa, Flynn and Jane. Jane has 8 marbles. Jane has half as many marbles as Flynn. Flynn has 4 times as many marbles as Lisa. Write the numbers of marbles they each have as a ratio. Give your answer in its simplest form. So straight away, because it's saying give answer in simplest form, I'm not writing anything on my answer line. I'm going to do it all in my working out space to start off with. So we have Lisa, Finn and Jane. Okay. So they tell us that Jane has 8 marbles. So I'm going to pop 8 marbles underneath Jane's initial there. Jane has half as many marbles as Flynn. So 8 is half of what Flynn has. So 8 times 2 is 16. Flynn has 4 times as many marbles as Lisa. So we divide Flynn's number of marbles by 4. That tells us what Lisa has. So now I have a ratio here to start off with, but I need it in my simplest form. So I need to simplify this ratio. So now I need to look at all 3 parts. A number that I could divide all 3 parts of that ratio by. Got to be able to divide them all by the same thing. 4, 16 and 8 are all even numbers. So I'm going to start by dividing by 2. So when I divide everything by 2, 4 divided by 2 is 2, 16 divided by 2 is 8, and 8 divided by 2 is 4. Again, they're all even. So let's do that again. 2 divided by 2 is 1, 8 divided by 2 is 4, 4 divided by 2 is 2. Now we've got to the point where there isn't a number that I can divide them all by other than 1. So that is our simplified ratio. So it's 1 to 4 to 2. Part B. Shan is trying to write 2 meters to 30 centimeters as a ratio in its simplest form. Here's her working. So she started with 2 meters to 30 centimeters. Then she simplified it to 1 meter to 15 centimeter. And her answer is 1 to 15. Okay, explain why her answer is not correct. So the important thing here is, guys, one measurement is in meters and one measurement is in centimeters. To be able to simplify ratios and work with them, everything has to be in the same units. So you can explain this however you want. I'm going to say exactly what I've just said. Everything should be in the same units before simplifying. There we go. 13a, reflect the triangle T, so this triangle here, in the line y equals 2. Okay, so they've given us a mirror line to reflect it in, so we need to draw that line onto our graph. The line y equals 2, every point on that line, the y coordinate is 2, so we're going to go up to positive 2 on the y-axis, and we're going to draw our mirror line. Once we've done that, that's the line that we're reflecting the shape T over. So we're going to take it at a corner at a time. So if we take this corner, it's 1 away from the mirror line. So it has to be 1 away from the mirror line on the other side. Let's take this next corner. It's 1, 2, 3 away from the mirror line. So we have to be 1, 2, 3 away from the mirror line on the other side. Bearing in mind that when we're counting these, guys, it has to be on the corners of squares. Don't count randomly in the middle of a square. You're going to go wrong because the shape needs to stay exactly the same size. All that's happening is it's flipping over that line. And then for the next corner, it's 1 away. So we go 1 away on the other side. And then once you've got all of your points lined up, draw in your shape. Squeaky ruler. And remember, it shouldn't change size. It shouldn't rotate in any way. All that should happen is that it flips over that mirror line when it's horizontal or vertical. Okay, so that's our reflection there. Part B, shade the least number of squares in the lower 2 quadrants so that the grid has rotational symmetry of order 2. So what rotational symmetry of order 2 means, that is if we turn this shape around a full circle, it will only fit into itself exactly twice. Okay? So for that to happen, we need to colour in diagonal quadrants to be equal. So we want these 2 quadrants to be matching and these two quadrants to be matching, because when we turn, so if we do a half turn, this quadrant will match here. And then when we get back to the beginning, when we've done a full term, these quadrants will match accordingly. So we're just going to colour in some shapes. So order of rotational symmetry 2. So we want diagonal quadrants to match. So I'm going to colour those 4 in, and then this one, and one, 2, this one. There we go. It's not the best colouring in the world. Okay, 14A. Suzanne drives from Liverpool to Hull. She drives at an average speed of 52 miles an hour for 2.5 hours. Calculate the distance that Suzanne drives. Okay, so speed is distance divided by time. We want the distance. So distance is speed times time. So we have a speed of 52 miles per hour, and we have time as 2.5 hours. Really important to check that our miles per hour units match our time units. So we've got miles per hour and our time is in hours, so we can work with them exactly as they are. So we're going to do 52 times 2.5. I'm going to times this by 10. So I'm going to do 52 times 25 to start off with. So 52 times 25. 5 times 2 is 10. That's 25, that's 26. 2 times 2 is 4. That's 10. That's 0, 0, 3. So that's 1,300. But because I'm multiplying by a decimal, I need to reverse that multiplied by 10. So 1,300 divided by 10 is 130 miles, because our time was in hour and our speed was in miles per hour. So I'm going to pop 130 on the answer line. 14B. Suzanne planned her journey using a map. The map has a scale of 1 to 200,000. On the map, the distance between two roundabouts measures 3 centimetres. What's the actual distance in kilometres? Okay, so let's start with a little proportion table. So we have 1 centimetre is 20,000 centimetres in real life. The distance on the map is 3 centimetres. So we're going to do 1 times 3, because when we're working with, so this is the map and this is real, should label that. When we're working with scales and proportions like this, we use scalar multiples. So that would be 600,000. But remember, this is in centimetres. We want it in kilometres. Okay, so to go from centimetres to metres to kilometres. So centimetres to metres, we would divide by 100. Metres to kilometres, we would divide by 1,000. So we're going to do 600,000 divided by 100. So that is 6,000 metres. But then we need to go from metres to kilometres. So then we're going to do 6,000 divided by 1,000, which is 6 kilometres. And we're going to pop 6 kilometres on our answer line. 15, factorise 3a, add 7ab. So when we're factorising, we need to pull out the highest common factor of the two terms. So let's split this up. So we can write 3a as 3 times a, and we can write 7ab as 7 times a times b. So look at these now. What do they have in common? Each of these terms has a factor of a in common. So I'm going to pull that common factor of a to the outside of a bracket. There's no other common factor that I can pull out of both of those terms. So inside my bracket, where 3a would be, I'm going to put the 3 and then we are adding, because it's an add, what's left of the 7ab term, which is 7 times b, which is 7b. So you pull out the highest common factor and then put the remainder inside the bracket. Part B, make W the subject of the formula y equals 5W subtract 4. So we are rearranging, okay? We are rearranging this equation. So we currently have y equals 5W minus 4. We want it to end up being W equals. So the first thing I'm going to do is I'm going to eliminate the minus 4. I'm aiming to get the W term on its own. To eliminate the minus 4, to get rid of it, the inverse of subtracting 4 is to add 4. Be careful here. When I add 4 to the left-hand side, I'm not adding it to a number, I'm adding it to a letter. So I have to write that really clearly. And then when I add 4 to the right-hand side, that eliminates the minus 4 and leaves me with 5W. Now, remember, we are aiming for W on its own. Currently, I have 5W. 5W is 5 times W. The inverse, the opposite of timesing by 5, is to divide by 5. Again, be careful here. When you divide the left-hand side by 5, everything is getting divided by 5. So you have to write it as a fraction, exactly as I've just done there. And then when you divide 5W by 5, that leaves you with W. So I'm just going to copy this now over to where my W equals is, just to make it nice and clear. So I've rearranged it, so W is equal to y plus 4 divided by 5. Question 16. In the diagram below, BE is a straight line. So this whole line is a straight line. Show that x equals 150 degrees. So we're trying to show that this angle here is 150 degrees. You must give a reason for each step of your working. So every time I think of an angle fact that I'm going to use to help me solve this problem, I'm going to write that angle fact down. Okay, so let's see what we know. Looking at this, I'm going to start working with this triangle here, ABC, because these dashes that we can see here tell me that that's an equilateral triangle. So I'm going to start by writing my first angle fact. Equilateral triangles have 3 equal angles, because they have 3 equal angles and 3 equal sides. So 180 divided by 3 is 60. So each of these angles is equal to 60. So as soon as I use an angle fact to work something out, I'm writing that angle fact down and then putting my working out down. Fantastic. The next thing I'm going to use is this is a straight line, okay? And I know that angles on a straight line add to 180. So these two angles, the 60 and this angle here, must add to 180. So 180 take away 60 is 120. So this angle here is 120 degrees. The next thing I'm going to work with, guys, is this triangle here, okay? And these two dashes that are marked on there tell me that that triangle has 2 equal sides. So this is an isosceles triangle. And what I know about isosceles triangles is base angles are equal. So this angle and this angle, the angles at the feet of those equal sides must be equal. So I'm going to write that down. Isosceles triangle has 2 equal base angles. Or you can just say base angles in an isosceles triangle are equal. However you word that, guys. The important thing is you get the word isosceles and you get the word base angles and you get the words equal. So I'm going to do 180, take away the 120 that I know, that I've just worked out, which is 60. But then I'm going to do 60 divided by 2 because each of these base angles are equal. Okay, last step. I can now use angles on a straight line again to find out what x is. So x is 180 degrees, take away that 30, because angles on a straight line add to 180, and I've already written that rule down, so I'm not going to write it again. So x equals 180 subtract 30, which is 150 degrees, which is what they wanted us to show. (17a). Calculate 0.4 divided by 0.01. Okay, so we're doing a division calculation. So I'm doing 0.4 divided by 0.01. Okay, when I'm dividing decimals, what I want to do is multiply both decimals by the same power of 10. And that power of 10 will determine that power of 10 is going to make them be integers. So I know that if I times 0.01 by 100, that's going to give me 1. I would normally times 0.4 by 10, but because I'm dividing, I have to times them by the same thing, guys. If I don't, I'm going to get the wrong answer. So 0.4 times 100 is 40, and then I do 40 divided by 1, which is 40. Now, the good thing about division is because I multiply both sides by the same thing, I don't need to reverse that. So my answer is actually just 40. Part B, calculate each of the following. Give your answers in their simplest form. So we're working with fraction calculations here. So the first one is 1/4 add 3/5. To add or subtract fractions, we need that common denominator. The bottom number, guys, I can't spell. The bottom number needs to be the same. There we go. So I need to make that bottom number the same. Now, you can find the lowest common multiple of 4 and 5, or you could simply just do 4 multiplied by 5 and use that number. So I'm going to do 4 times 5 to get 20, and then I'm going to do the 5 on the bottom times 4 to get 20. But what I have to remember to do is do the same to the top. So on the left hand side, I'm doing 1 times 5, and on the right hand fraction, I'm doing 3 times 4. Now that we have our common denominator, we can add the numerator. So the denominator stays as it is, and then I'm doing 5 plus 12 on the top. So that gives me 17 over 20. That is in its simplest form because 17 and 20 don't have a common factor that I can divide them both by that isn't 1. So that's our answer. Part 2, we're doing 5/6 multiplied by 3/10. When we're multiplying fractions, we multiply the numerators together and the denominators together. So that's 5 times 3 is 15, 6 times 10 is 60. This one can be simplified further. Now straight away I spot I can divide by 15. So that would be 1 on top and 4 on the bottom. You could have divided by 5 and then divided by 3. It doesn't matter how many steps you take as long as you get to the correct answer. 18. The diagram below shows rectangle ABCD. So we've got ABCD as a rectangle. AB equals 2x plus 3. BC equals 12 centimetres. The perimeter of the rectangle is 40 centimetres. That's all the way around the outside. Calculate the value of x. So we want to form an equation for the perimeter, guys. So it's a rectangle, so opposite sides are equal. So these I'm going to mark like that. And then to get the perimeter, we would add up all of the sides. So we would have 2x plus 3 plus 12 plus 2x plus 3 plus 12. And they've told us that should equal 40. So let's do some algebraic manipulation. We've got 2x plus 2x. So that gives us 4x. And then we have 3 plus 12, which is 15, plus 3, which is 18, plus 12, which is 30. So that's 4x plus 30 is equal to 40. Now we're going to solve this equation because we want to know the value of x. inverse operations when we're solving equations, guys, the first thing I want to do, I want to eliminate that plus 30, because when I'm solving for x, I'm aiming to isolate the x term. So the inverse of adding 30 would be to subtract 30. So the left-hand side becomes 4x, and the right-hand side, 40 subtract 30, becomes 10. Now I have 4x equals 10. 4x is 4 multiplied by x. The inverse of multiplying by 4 would be to divide by 4. So x equals 10 divided by 4. However you want to do that, guys, I know that that's 2.5. And that's the answer to this question. Question 19. Write down 5 positive whole numbers in the boxes below. So these boxes here, such that the numbers have, so we've got some criteria to meet, a range of 5, a mean of 4, and a median of 3. Okay, so range of 5. So remember, the range is the biggest take away the smallest. That's the difference, that's the spread. The mean is the average, where we add them all together and then divide by how many we have. And then the median is the middle number, okay? So we need 5 whole numbers, okay, positive whole numbers that meet those criteria. So we want our biggest and smallest numbers to have a difference of 5. We want the mean to be 4 and the median to be 3. So the first thing we're going to work with is the mean. We want it to equal 4. We've got 5 positive whole numbers. So what we would have done is add all of those numbers together and then divide by how many we have to get the mean. So we would have divided their total by 5. So their total must be the mean times by 5. So we're looking for 5 numbers that have a total of 20. Okay, so we've dealt with the mean aspect of it here. As long as all those 5 numbers add to 20, the mean aspect is covered. We want the median to be 3, but we want the range to be 5. So there's probably a variety of different numbers you could use here. If I want the median to be 3, I'm going to start by having my middle number as 3, because if I write them in order and I cross them off on either side, that middle number being 3 would give us that median. So now what we need to think of is, what would our smallest and biggest number be? Because we want them to have a difference of 5. We want them to have a range of 5. So if I, for example, have my smallest number as 2, my biggest number must be 7, because they need to have that difference of 5. So far we have 2, 3 and 7. So 2 plus 3 plus 7. 2 plus 3 is 5 plus 7 is 12. So far we're up to a total of 12. So we want these 2 numbers here to make the difference between 12 and 20. So these 2 need to add to 8. And they either need to be between 2 and 3. Can't happen, because we need integers, whole numbers. So they'll either have to repeat 2 and 3. So we could put here 2 and 6, because 2 plus 6 is 8. 3 is our median. The difference between our biggest and our smallest number is 5. That's our range. And the total is 2 plus 2 is 4, plus 3 is 7, plus 6 is 13, plus 7 is 20, which is what we need our total to be. There's lots of other combinations you can use. So if you did this without seeing my answer and you've got a different one, as long as you meet those criteria, you will be fine. So there's more than one solution to this question, guys. Question 20. Robin makes the 2 cubes below from centimetre cubes. So we're working in centimetres. Sarah uses all of Robin's centimetre cubes to make a single cuboid. Each of the dimensions of Sarah's cuboid will be greater than 1 centimetre. Give the dimensions of a cuboid that Sarah could make. So what's happened is Sarah's going to combine both of those cubes and then make a cuboid that has all of those cubes involved. So this is actually a volume question, guys. but we have cubes to work with, which is wonderful. So first of all, let's see how many cubes Robin has used in total. So this one is 2 by 2 by 2. So 2 times 2 times 2, that's 8. So there's 8 cubes in total in the smaller shape. So this one is 4 by 4 by 4. 4 times 4 times 4 is 64. So there's 64 cubes in total. Okay. Now we need to figure out the total number of cubes because Sarah is putting them together. So 64 plus 8 is 72. So there's 72 cubes in total. So if I sketch a quick cuboid just to demonstrate how this would work. So we would have length times width times depth. So we would do length times width times depth and we would get 72. Okay, so we need to figure out how we could make 72 using 3 numbers. Well, 72 is an even number, so I could do 2 times something to get 72. Well, 72 divided by 2, that would be 336. So that would be 2 times 36. All right, but I want 3 measurements. So if this was 2, I need 2 numbers that would make a product of 36 here. So again, 36 is even, so I could have 2 times 2 times something. Well, let's do 36 divided by 2. 18. So I could say that the measurements of this cube, the dimensions, could be 2 centimetres by 2 centimetres by 18 centimetres. There's lots of other combinations you could have used, guys, as long as when you multiply those 3 numbers together, you get an answer of 72. 21A, estimate the value of the sum, show all of your working. So when we're estimating, it's making our lives a little bit easier. We round everything to one significant figure and then carry out what we hope is a simpler calculation. So I'm going to round 2.13 to 2. I'm going to round 99.4 to 100, and then I'm going to round 39.5 to 40. So let's rewrite that. 2 times 100 divided by 40. Your first mark is rounding everything to the one significant figure, so to make it an easier number to work with. Let's evaluate the top. 2 times 100 is 200, and then we're doing 200 divided by 40. Well, I can divide top and bottom by 10, so what I'm actually doing is 20 divided by 4, which is 5. So 5 is my estimate. Part B. Given that 3.4 times 7.8 is equal to 26.52, write down the answer to each of the following. So part 1, we have got 34 times 78. So 34 times 78 is equal to something. Now let's compare this to the original place value calculation we're given. So what they've done here is 3.4 has been multiplied by 10. 7.8 has been multiplied by 10. So we need to do the same to our answer, guys. So we need to multiply our answer by 10 and by 10 again. So we are doing 26.52 times 10, which is 265.2. And then we're going to times it by 10 again, which is 2,652. And that's my answer. Part 2. Here we are doing 26.52 divided by 34. So if we take the original one a little bit further down, so 3.4 times by 7.8 equals 26.52, but they've rearranged it. So if I rearrange this to match 26.52 divided by 3.4, okay, so let's have a look at what's happened. Our 3.4 has been times by 10. Our 26.52 stays the same, but we're still going to have to change the answer of 7.8. Now, because we rearranged the equation, we actually have to do the opposite. So rather than timesing by 10 to match it, we're going to have to divide by 10. So this answer of 7.8 is going to be divided by 10. So that's going to be equal to 7.8 divided by 10, which is equal to 0.78, because we rearranged that equation. (22a) write 2475 as a product of its prime factors in index form. Okay, so we're going to do a prime factor tree. So 2475, two numbers that multiply to give me 2475. Now it ends in a 5, so I know I can definitely divide by 5, and 5 is a prime number, so that ends that tree straight away. So let's do 2475 divided by 5. 5, 10, 15, 20, 25, 30. Okay, 5's into 24. 1, 2, 3, 4. Remainder 4. 5's into 47. Let's go a little bit further. 1, 2, 3, 4, 5, 6, 7, 8, 9. Remainder 2. 5's into 25. 1, 2, 3, 4, 5. No remainder. So 5 times 495. Now I need to continue this branch, so two numbers that multiply to give me 495. Again, handily, it ends in 5, so I can divide by 5. So 495 divided by 5. So we're doing 4's into 49. 5's into 49, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. With a remainder of 4. And then 5's into 45, we've just counted that as 9, so that would be 99. Now, two numbers that multiply to give us 99, well, that's in the 3 times tables, and 3 is prime. That would be 3 times 33. Two numbers that multiply to give us 33, that would be 3 times 11, and both of those are prime. So I would write this as 5 times 5 times 3 times 3 times 11. Product means multiply, but they want it in index form, so we can simplify things. We can combine our 3 times 3, and we can combine our 5 times 5. So 3 times 3 can be written as 3 squared, multiplied by 5 times 5, which can be written as 5 squared, and then multiplied by 11. So that's our final answer in index form. Okay, part B, write down the square root of 64 multiplied by 5 to the power of 4 multiplied by 7 to the power of 4. Give your answer as a product of prime factors in index form. So I'm going to take each part of this number here separately. So I'm going to do the square root of 64, which is 8. I'm going to do the square root of 5 to the power of 4, which would be 5 squared. And then we'll do the square root of 7 to the power of 4, which would be 7 squared. So this would be 8 times 5 squared times 7 squared. However, we want it as a product of prime factors, so I need to split 8 into its product of prime factors. So that would be 2 times 4, 2 times 2. So 8 can be written as 2 to the power of 3. And then we've got times by 5 squared times by 7 squared. Oh, too far. 23. Pippa and Joe are working on a school project. The project is based on the use of the local leisure facilities. Part A. Pippa decides to ask adults how much they spend on gym membership each month. In the box below, write a suitable question with appropriate response boxes to collect this information. Okay, so when we're writing a suitable question, the first thing we need to do is include a time frame in the question. Okay, we can't just say how much do you spend on the gym, because they'll be like, well, what do you mean? Every year, every month? So we need to give a time. So let's say for our question, how much do you spend on a gym membership each month? So we've included a time frame in that. Okay, so we need to write our response boxes. The important thing about the response boxes are you've got to include all possible amounts, including 0, that they could pay for their gym membership, but you don't want any overlaps. You don't want it to be confusing for people to potentially be able to tick more than one box. So we're going to work with inequality. So let's say, let's go 0 to £10. Okay, 11 to £20, and then 21 to £30, and then £31 and above. All right, so we've got a box for 0, we've got a box for anyone that spends more than £30, but then the other boxes are there and appropriate, and there's no overlap. So I couldn't do 0 to 10, 10 to 20, 20 to 30, because then there's multiple boxes that 10 and 20 could go into. We don't want to confuse things. Okay, part B. Joe asked some adults how many hours they each spent at the leisure centre during the previous week. His results are shown below. Joe accurately calculated an estimate of the mean time spent per adult to be 7 hours. In his project, he stated, on average, the adults in my survey each spent 7 hours at the leisure centre last week. Explain why the mean is not the best average to use for this data, okay? So the mean is not the best average to use because if you've got one really big outlier, so say somebody spent 50 hours at the gym that week, that would really skew the results when we're working out the mean, because we do the total. So that 50 would raise that total, and then we would divide by the number of people. So I'm going to say that the mean, so it can be affected by outliers. All right, by that I mean like an extreme value. Okay, part 2. Give one other reason why Joe's results may not be reliable. Well, let's have a look. How many people did he ask in total for starters? So 9 plus 2 is 11, plus 1, 12, plus 1, 30. He's only asked 15 people. He's not asked enough people, really. So it's a really small sample size. So we're going to put small sample size, should have asked more people. All right. 24. An empty water tank is filled using a hose with a steady rate of flow. The tank takes 30 minutes to fill if the water is added at X litres per minute, 40 minutes to fill if the water is added at X minus 2 litres per minute. Form an equation in terms of X and then solve the equation and hence find the capacity of the tank in litres. Okay, so it's a steady rate of flow, but we've got two options here. It can either take 30 minutes to fill or 40 minutes to fill. But either way, it's going to fill the same amount, isn't it? The size of the tank doesn't change. So we're going to form an equation, okay? So 30 minutes at X litres per minute would be 30 times X. And 40 minutes at X minus 2 litres per minute would be 40 times X minus 2. Okay, so let's form an equation. So they are filling the same tank. Okay, so we're going to write them equal to each other. And then I'm going to expand the bracket. So that's 40x minus 80. And then I'm going to solve the equation. So I'm going to subtract 30x from both sides. And then I'm going to add 80 to both sides. And then I'm going to divide by 10. So X equals 8, okay? Fills at 8 litres per minute and it takes 30 minutes. So let's just use one of those expressions that we formed. So if it takes 30 minutes to fill 8 litres, that's 240. So it must be 240 litres in the tank altogether. 25, 3 friends, Louis, Crystal and Jamal win some money in a competition. They share the money in the ratio 3 to 7 to 11. Part A, what fraction of the total of money won is given to Jamal? So we have Louis, Crystal and Jamal, 3 to 7 to 11. Okay, we're interested in what fraction of the total is given to Jamal. So we're interested in this part, but the total is how many parts there are in total. So 3 plus 7 is 10, plus 11 is 21. So Jamal gets 11 out of 21 parts. Part B, Jamal spends £45 of the money he won. He now has exactly twice as much as Louis won. How much did Crystal win? Okay, so Jamal spends £45 of the money he won. And when he spends that £45, he has exactly twice as much as Louis. So if Louis's got 3 parts, after Jamal's spent his £45, he should be left with 6 parts. So the difference between 11 and 6 is 5 parts. So that 5 parts must be the £45 that he spent. So let's find out what that means 1 part would be equal to. So we need to divide by 5. So 1 part is equal to £9. How much money did Crystal win? Well, this part of the ratio is Crystal, and that's 7 parts. So we would do 7 times £9. So Crystal wins £63. Question 26. 6 printers take 36 minutes to print a number of identical booklets. How long will it take 9 printers to print half as many of these booklets? And we're assuming that the printers print at the same rate. So the first thing to recognise is we're working with inverse proportion here, because the time it takes 9 printers would be quicker than the time it takes to 6 printers. So we're going to end up working with inverse proportion. So I'm going to use a proportion table because that just makes more sense for my brain. So let's go with printers, booklets, and then time. Okay, so we have 6 printers. They print a number of booklets, let's call that X, and it takes them 36 minutes. All right, I'm going to try and scale that up now, because what I want to happen is to end up with 9 printers that print half as many books, and I want to figure out what that time is. So I'm going to divide by 6 here. So divide by 6 and find out 1 printer. Okay, so 1 printer, this is where the inverse proportion comes in. I need to times by 6 here, because 1 printer would take longer than 6 printers. Okay, so that gives me 216. Now I want to get to 9 printers, so I'm going to times by 9, which means on this side I would divide by 9, because it would take 9 printers less time. So let's do 216 divided by 9. 9, 18, 27, 36, 45. So that's 1, 2, remainder 3, and that's 4. So that would be 24. Okay, but let me get rid of that to save confusion. That would be currently for the same amount of booklets. Okay, but we want the time it would take for 9 printers to do half as many booklets. So it would take them half the time. So 24 divided by 2 is equal to 12. So it would take them 12 minutes. 27A. The price of an item in a sale has been reduced by 25%. If the sale price is £54, what was the original price? Okay. Again, I'm going to use a proportion table. So we have the price and how much it's been reduced by, and the percentage of it. If it's reduced by 25%, 100 minus 25 is 75%. So that £54 is 75%. We want the original 100%. So what I'm going to do is I'm going to divide by 3 to get 25%. So 54 divided by 3. So I'm just scaling up and down accordingly. So that is not 2. That is 1 remainder 2, and that is 8. And then I would times by 4 for the original. So the original cost is £72. Part B, percentage change can be calculated using multipliers. A number is decreased by 33% of its value. Circle the multiplier that would find the value after this decrease. If we're decreasing, it would be 100 take away 33, which is 67%. 67% as a decimal is 0.67. Okay. Part 2. A number is increased by 6% of its value. This is done 3 times, each time increasing the previous value by 6%. Circle the multiplier that would find the value after 3 increases. So first of all, increase of 6% is 106%, which is 1.06. That's happening 3 times. That's a compound change. So it will 1.06 to the power of 3. 28. 3 friends, Luca, Marley and Nina, buy some fruit. Luca buys 3 apples and 4 bananas and pays £2.70. Marley buys 2 apples and 3 bananas and pays £1.95. Use an algebraic method to calculate how much Nina pays for 4 apples and 2 bananas. So I'm going to form and solve some simultaneous equations here, because the apples and the bananas individually cost exactly the same regardless of who buys them. The price doesn't change. So for Luca's purchase, we're going to do 3a plus 4b equals 2.70. And for Marley's, we're going to do 2a plus 3b equals £1.95. So I have equation 1 and equation 2 here. Now I'm going to compare the b's, and I want them to have the same coefficient. I want the same number of b's. So I'm going to times this equation by 3, and I'm going to times this equation by 4. Okay, so that'll give me 2 new equations. So when I do equation 1 multiplied by 3, everything gets multiplied by 3. So 3a times 3, 4b times 3, and then £2.70 times 3, that's £8.10. And then the same here, but I'm timesing by 4. Everything gets multiplied by 4. So 2a times 4 is 8a. It gives me 12b. £1 times 4 is £4. 95. 95, that's 10. It's 3/8, so that's £7.80. And then we're going to solve these equations. So I made my y's the same because then it means I can easily spot what I need to do to eliminate a variable. So those signs are the same. So what I need to do is subtract these equations from each other. That's the only way I'm going to eliminate the b's. So 9a take away 8a is a. 12b take away 12b eliminates it. £8.10 take away £7.80 is 0.30. So an apple is 0.30, which is also 30 pence. Now I know what an apple is, I can substitute it back into one of my equations to find out how much bananas cost. So let's just use equation 1. So 3 times my apple plus 4 bananas is equal to £2.70. So that's 3 times 0.3 is 0.9. So 4b is equal to £2.70, take away 90 pence. So b is £1.80 divided by 4. that's 0.45. So that's 45p. Okay, we need to figure out how much Nina pays. So she pays for 4 apples and 2 bananas. So 4 apples is 4 times 30p, which is 120p. 2 bananas is 2 times 45p, which is 90p. So 120 plus 90 is 210 pence, or £2.10. It doesn't matter which one you pop on the answer line, guys. 29a, calculate the value of this sum. Give your answer in standard form. So this is a division sum, guys. So what we're technically doing is 1.29 times 10 to the power of 5 divided by 3 times 10 to the power minus 7. So when we're dividing in standard form, we're going to do 1.29 divided by 3. So 1.29 divided by 3, which is 0.43. And then 10 to the power of 5 divided by 10 to the power minus 7. When we're dividing, we subtract powers. So that's 10 to the power of 5 minus 7. I've written that out because I need to be careful of that double symbol, which becomes 10 to the power of 5 plus 7, which is 10 to the power of 12. So when I write this out, I have 0.43 times 10 to the power of 12. Once my answer in standard form. For my answer to be in standard form, this needs to be between 1 and 10. So I'm going to have to multiply it by 10 to make it 4.3. But because I've multiplied by 10, I need to reduce the power by 1 by dividing by 10. So that is my answer in standard form. Part B, calculate the value of this sum. Again, give your answer in standard form. So when we're adding or subtracting in standard form, you can either convert them to normal numbers, add them and then convert them back, or you can make the powers the same. Okay, I'm going to make the powers the same. So I've got 7.6 times 10 to the power of 5 and 3 times 10 to the power of 4. Okay, so I'm going to make this one be 10 to the power of 5. So to be 10 to the power of 5, I would need to multiply by 10 here, which means I need to divide by 10 here. So 0.3 times 10 to the power of 5. So now what I'm doing is 7.6 times 10 to the power of 5 plus 0.3 times 10 to the power of 5. And because our powers are matching, we can simply add the numbers. So we are doing 7.6 plus 0.3, which is 7.9 times by 10 to the power of 5. Just double checking at the end that that number there is between 1 and 10. It is, so I can leave that as my final answer.